Hey, what is going on? It is Saturday, April 23rd, 2022. Welcome to Coding with Chef, and I have another video for you. It's this fine Saturday. I'm ready to get coding on some hash maps. I missed the last few days. Again, I was super busy with my day-to-day job, the bread and butter thing, and this kind of had to take a slight secondary. I didn't want to have a day where I didn't do a coding problem, but I'm making up for that today. And considering that it's a weekend, hopefully, yeah, this is an easy one. And this is an easy one, I think, but this is a tricky one, I think, also. So the problem is 2190 on Leetcode. And by the way, before I start, please like, subscribe, and leave a comment. I have the link in this video. Yeah, it would help really with the algorithm and getting my work visible. And yeah, all the code is my own. I write the solutions on Leetcode in a discussion. I'll link the discussion also, so you can see where I have the solution mapped out. And yeah, you can follow along. I try to do these solutions all right from the get-go, and without like any sort of help initially. And then if it becomes too difficult, then I look for the solutions. That's the best way that you can, best thing you can do for yourself if you're kind of training to be good at competitive coding, interviews, algorithms. You really got to learn this stuff. Don't memorize. Anyway, so that's what I'm here to help you do, I think. Yeah, so here you go. So problem 2190, most frequent number following key in an array. Okay. You are given, this is labeled an easy, but when I clicked on the acceptance rate of this, the acceptance rate was 60%. And that's actually a better indicator, I think, of how difficult the problem is rather than this tag here that says whether it's easy or hard. Because there are some problems that are labeled hard that are like actually pretty easy and the acceptance rate is pretty high. But then there's some problems labeled easy where the acceptance rate is really low, and there might need to be an algorithmic way of updating that. But anyway, we'll get into that another time. So most frequent number following key in an array, you're given a 0 indexed integer array nums. You're also given an integer key which is present in nums. For every unique integer target in nums, count the number of times target immediately follows an occurrence of key in nums. Okay, wow. In other words, count the number of indices I such that I is less than nums length minus 2, nums of I equals key, nums of I plus 1 equals target. Return the target with the maximum count. Test cases will be generated such that the target with the maximum count is unique. Okay. Now the wording of this problem is tricky, and this is not a, so you see the word count here, right? And you gotta really understand what is counted. Okay, so you might be tempted to just have a hash map here of some kind, so you can count the keys occurring and the number of or something like the number of occurrences of the key value here. But again, this is not as super straightforward as it looks at first. But we can suss out a solution, but let's look at what's being counted first. Okay, so we are looking for a target. Here's the example. We are looking for the key. The key is 1, right? So for target 100, there are two current occurrences, indices 1 and 4, which follow the occurrence of key. So that's right. 1 follows 100. 1 follows 100. So there's, again, not everything is like labeled as a key value pair either. That's one thing you have to keep in mind. There are an odd number of elements in this array, and so you're not going to have always an even number of elements. That's something important to make a note of. But as long as you have two consecutive elements, two elements following the key value pair association, such that the key is equal to 1, or the target, or the input value, then you can count the number of the associations, right? And here's the trick. You count the number of the associations that have a value that is of the maximum count for that key value pair. So basically the key value pair that occurs the most number of times with a given key, return the value associated with that list of key value pairs. Okay, so here's another example, right, that elucidates it a little better. If you have 100, 335, 100, 100, another 100, 100, 34, 100, and then yeah, let's do another two. No, let's do 100. Okay, so here's, like, take a look at this. Okay, you have 100 appears once, 100 appears again, 100 appears again, 100 appears again. So, okay, you would, okay, so yeah, let me also change this to 110 and 110. This will elucidate this better. So the pair 100, and let's say we're looking for key 1, as in the first example. 100 appears how many times? 4 times. How about 1 and anything else? We have 1 and 10 appears 2 times. Okay, we have 2 100 appears 3 times. Yeah, 2 times, right? And we have 334 appears once. Okay, so right off the bat, we don't care about these, right? Even though the 100 is similar here with these 2 keys, we don't care here because the key is not the input key. Key is not equal to 1, so who cares? Now this is where the keys the key equals 1 is important, because there's 2 key value pairs found in this array where the key equals 1. But the key equals 1 most for a key value pair where the value is 100. Okay? And since that's the case, since it occurs 4 times, you can disregard the lesser occurring key value pair and return 100 being associated with the key for the list of key value pairs that appears most frequently. Okay, I hope this is clear. We'll operate with this assumption. So, what should we do here? Okay, so this is a case where we want to do a map of maps, because I'll show you in a minute, a simple count map won't do, because we have to count the count of something else, right? Namely the count of the key value pairs that are satisfying the condition we outlined. Int max value counted. Now what is this? Okay. Now this is a little bit of a misnomer here, in max value counted, but this is basically that 100 in this example, okay? So it's not the maximum. Like, for example, if you had 1 and 200 and you had 1 occur once and 1 and 100 occur twice, you'd still return 100. So maybe max value counted isn't the best name, but let's go with it. Hopefully the algorithm, hopefully it makes sense in context. So what I'm gonna do is length -1. We're only going to go to -1 because we don't have to go to the very end of the array, because we're looking for anything that follows the key value pair paradigm, which means first index key, second value, second index value. So anytime we get a positive match for the key that's input, in this case key, right? And in the last example it was 1. We will can't type today. We are going to create this new map, key value count map, right, equals count map dot, I like the autocomplete on Leetcode, get or default, because we want to get the number of occurrences of that key, or a map of the number of occurrences of the key, or new hash map integer. We want, or we get that, or we get yeah. Okay. Yeah. Okay. So this is what we do. Okay. So you'll see why I did this new hash map here, but basically this is where we're getting our mini map here. Okay. If you can kind of like suss that out. Okay. So now we're going to count map get or default. Okay, nums I plus 1. Now we're getting the value, the count of the values, right? Okay, because first we got the count of the occurrences of the key, which is associated with a map of potential values. And this is the map of those values, right? And I'm calling this incr. I'll show you why in a second. Key value count map dot put I plus 1. Okay, so I'm incrementing the total number of the occurrences of that key for that key value pair, and thus I'm incrementing the total number of key value pairs. Okay, I talked about that before, right? That's the thing that you have to really understand. So now I'm checking the max count of the key value pairs for that specific value, well, for any value we run across, and seeing if the max count, if the current key value pair count for that value is greater than the max count that exists already for all the key value pairs, then we reassign max count, and we call max value counted as the value for this current key value pair. Okay, so again, this is a little, the wording and algorithmic process, I think, can be a little tricky and requires some thinking, but basically this is what's happening. Let's see if this works. Seems to work against the test, run against the whole thing. Let's see, what did I do wrong? Okay, we just have to make sure that our key value is correct. Okay, if max value is less than, no, this is what I needed to, this is one thing I forgot to do. The count map has to be re-updated. This is important because this is, even though you're referencing this object, it doesn't mean that it's been updated. Okay, so once you update a map, right, after you've associated with a key value pair, you have to put it back, or it's best to put it back in to make sure it truly gets updated. Otherwise, the map is still referenced, but it never gets updated in count map, right? The map of the map. So, yes, very tricky. Run that, and there you go. Okay, that's the right answer. And yeah, we're done. So the runtime of this should be of O of n, because we're really just going through these values one by one, right? We have all these maps that we're accessing and doing like a little internal work, but they're all O of 1 as well, because we're just doing a lookup in a map that's an O of 1 operation, all right? And a constant time operation, relatively speaking. And again, the space is, since we have a map of maps, the space could be, it's O of n, but it's slightly higher than O of n. we can call it O of n for our purposes, because it folds into O of n. But that's, yeah, it's mostly a factor of the number of key value pairs that exist that have to be stored for a specific value. So it's actually a little less than O of n. Well, let's call it O of n, right? That's the worst case performance for this map. Okay, so yeah, that's it. If you like this video, please like, subscribe, etc. And I will see you next time. Stay coding and have a good day.